finance is a field that uses stochastic first, statistical techniques, and very advanced, I must emphasize, very advanced numerical computational methods to do many things, to analyze financial markets, price financial instruments, manage risks, develop investment strategies, optimize hedging, investing portfolios, etc. So these sound quantitative finance to me. And quantitative finance professional working in the field are called quantitative analysts. So quant is slang word. And so each quant often specialize in specific roles and specific products in finance. For example, I specialize in interest rate products, right? And you know, in the field, it's very interesting to understand a very long history of quantitative finance. Started with Louis Bachelier, and anyone working in the field should be familiar with Bachelier formula, which has been used intensively nowadays in interest rate modeling as well. The concept of Brownian motions to model stock price that Louis Bachelier described in his work. And the modern portfolio theories of Markowitz came in 1950s. Right? Markowitz is an American economist which established a quantitative approach to balancing risks and return in investment portfolios. That's the early foundations of the whole the modern quantitative finance that we see nowadays. And maybe in this history, the second building block that I would like to mention here is the rise of financial engineering during 60s and 70s. Maybe we start first with Blackstone model, which becomes a very fundamental model that has been used, everywhere in the quantitative finance world, right? Sometimes people say that Blackstone is too old and maybe it's not efficient anymore, but it might be true. This might be completely true somewhere, in some way, but Blackstone still plays a very important role for people working in the field, right? And the second important bullet point that I would like to highlight in the rise of financial engineering is the Wall Street adoptions during this time. I mean, investment firms began to employ mathematicians, physicists, engineers, computer scientists to develop pricing models, risk management tools, and trading strategies. Right. I mean, once upon a time when we talked about investment banking, working in financial institutions is were not that evident for mathematicians and physicists or computer scientists or other scientists to come to this world and working in Wall Street. It's not that evident back then. I mean, before the rise of financial engineering and the adoptions of Wall Street, right? And quantitative finance and quant professions came to its golden age during, 1980 to the very first year of the new century. First of all, because of the explosive growth of derivatives markets with more and more complex products. And I think it's very quite logic and simple to understand in this case that now the finance world, people in this world came up with more and more complex product, and they need some guy to understand and to be able to build to use and to build very complex mathematical models to solve the problem in finance world, to price, to manage the risk of complex products. right? So there's something changed here, right? In 1980s, and here came the algorithmic tradings became important in 90s due to the rise of computing powers, the sophisticated models for trading and risk management, right? I think this, we call it the golden age of the quant professions and quantitative analysts, because we could observe the increasing number of quant employed in Wall Street in different financial centers, like in London, in Paris, in Frankfurt, right? And the new era that I would like to mention here in the very brief history of quantitative finance started, I chose 2008, but maybe a little bit earlier or later, I'm not so sure, but let's agree with 2008 at the start of the new era. We started with global crisis in 2008 and 2009, and many things changed. I was not in this period because I was still in my undergraduate study. During, I have just finished my undergraduate study in this period, but many things changed because now with global crisis, right? People realize that even with very sophisticated and complex products, we still failed, right? We couldn't control the risk. People came up with very innovative, creative derivatives, but it just became disaster during the crisis. So they just talk that, jump to a very, I mean, quite extreme conclusion that's okay. So if all complex product didn't work, so let's just come back to a very basic and simple one. And here come the layoff of all, I mean, quantitative divisions, and it was a very hard time for people, right? So people now survive this period, and lucky enough to continue their professions and working in the field. I can tell you the very interesting story during the start of the new era. But I mean, there's much more positive sides than the global crisis, because I think people adapt and develop the domain much more. And I would like to emphasize two directions here. The first one is ML and AI and big data rise for portfolio hashing, for option pricing, for risk managing, forecasting, and more. The second one is beyond traditional finance that we can mention here as ESG, crypto, and fintech. So it's a very brief history. That's how I look at the professions, at the domains of quantitative finance, right? And because I think very natural that if you work in the field, there's always certain people that you look up to, that inspire you to continue developing, I mean, continue learning in the field. And I would like to mention a couple of people here, which I think is very inspiring. The first one is Simon. Simon is a very, I would like to mention first that he was a very seasoned mathematician with a theory named after him, and the legend Chen is a legendary mathematician as well. So Chen Simon theory. But after, I mean, creating Chen Simon theory, he founded Renaissance technologies, things like Renaissance technologies. It just become a giant hedge fund, and he's very famous for his medallion fund, and he actually is a billionaire. He passed away this year. I mean, it's just a very, I mean, respected persons in the field, and each time when we talk about investment banking or hedge fund, or how you can optimize or make profit from trading, you should hear about him, James Harris Simon. The second person I would like to mention is he's one of my heroes in the field is Mark Joshi. He's another mathematician turned quant. He's more very seasoned and inspiring quantitative researcher, the authors of multiple must-read books in quantitative finance. So if you work in the field, probably you heard about him. He passed away in 2017 due to some heart attack, right? But he's still inspired. I mean, many people in the field with very great books, right, in quantitative finance, right? The third person, I mean, Pierre-Henri Laporte, he French, a theoretical physicist turned quant. So again, another scientist now, right? Not a mathematician, but theoretical physicist. He is a 2 times award winner, Quant of the Year. And maybe the things I would like to mention here is his revolutionary ideas of applying, basically, let me put it simply, very complicated mathematics that even a mathematician working in a very abstract field didn't use it. So, right, he come up with the ideas, so great idea of applying such thing that apparently has nothing to do with quantitative finance, but eventually is used them to solve very, I mean, practical and central problem in quantitative finance. That's Pierre-Henri Laporte. The last persons I would like to mention here is comes from, I mean, different directions. Hans, right, German. He has a PhD in financial mathematics. So finally, someone actually do a quite a little bit more classical, I mean, classic study in the field, right? He started with financial mathematics instead of very pure math. He's Quant of the Year 2022. And why he becomes my hero? Because I think this guy with his collaborators, they have made magnificent works on developing deep learning techniques in portfolio hashing. And since their study, we saw a great applications of deep learning, I mean the AI, in finance. And it started in 2019, right? And I think it changed the whole things and inspire many people to continue in this mainstream, in this direction, to build and apply deep learning techniques in finance, right? So there are 4 people that I would like to mention. We come to things I would like to mention today is the different quant types in this form, because I think quantitative finance is a very large and developed domain. And as a professions, it has been evolving, I mean, for many decades. So there's a lot of a quant working in different role and types. So I would like to mention something here. But before we start, we really mentions different quant role. I would like to mention just one thing, is that normally when we talk about investment or tradings, you buy or you sell something, right? So you buy some stock and you sell once, right? So in these professions, there are always 2 sides. You come from buy side or you come from sell side, right? So this side detect a lot how we will react and how you will develop your professions actually. So buy side and sell side. Now let's come first with front office quant. Right, maybe this is the type that I'm familiar the most with. What I used to be a front office quant, and the signatures of these professions is they often work directly with traders, portfolio manager, sales, structurers, and other front office teams in financial institutions. Normally, administratively, they belongs to front office, right? And one of their primary goal is to research, develop, and directly implement pricing formulas for various financial instruments, right? I would like to emphasize the word directly here because there's one important aspect of front office one is that if you come up with some idea, some research, or brilliant mathematical formula, you have to implement it. You have to be capable of implementing it in the official pricing system of the company. Right? And one pricing, this is very important things. One pricing must go with a hedging strategy for risk controls, with market risk, with credit risk, credit counterparty risk, etc. When we talk about pricing, we do not just give a number, a price, but we come up with the strategies. The way we can control the risk for the whole period of the product. If the product lasts, the maturity is 20 years, we have to come up with a hedging strategy for 20 years, right? The second thing to mention here is, right, one pricing should be carefully tested by back testing processes with, historical data, right? And one important aspect of this quant type is a very high demand for fast and efficient solution in pricing, calibrating, and hedging. It's very common in this world that your solutions might not be used at all if it's slower than that of your competitors. Even if very precise, you cannot use it if it's too slow in front office. That's very important. It's different from the middle or the back office perspectives, right? And this aspect leads to a need for creative ideas in modeling and pricing. Is very important for a front office quant. That's the first type I would like to mention here. The second one is quant risk. You can see, right. I would like to state it first. So I mentioned that front office, normally they work in front office, right? Front office quant normally work in front office. Quant risk, normally they work in risk department, so in the middle office, right? And it, in this type of professions, there are many things to mention here, and it can change across continents. It's not the same in Asia, it's not the same in Europe or in Wall Street in America. But maybe there, some common things I would like to mention here. The first one is regulatory compliance. It's very important that quant risk, they care about the compliance, the risk compliance here. They have to ensure that all risk model and practice comply with relevant regulations. For example, when you are in Paris, right? So you have the central bank of France, just like SVB in Vietnam, right? The State Bank of Vietnam. And you have the the BCE as well, right? The central bank, European bank, right? Central European Bank as well. And there's a lot of regulations to follow. I mean, the Basel 2-3 fundamental review of trading books, some FFTB or IFRS, any kind, I mean 9, 7, 19, etc. And for documentations, but compliance is very important. So keeping detailed documentations of models and risk management practices for regulatory and audit purposes is very important. The second one I would like to mention is in the profession is risk assessment and reporting. The first of all, for risk management, I mean, naturally, I think almost one risk have to compute and monitor the VAR or SVAR, stress VAR, and run various stress tests every day to quantify potential losses, right? And they have to monitor positions as well to keep track of financial positions and their associated risk, ensuring they remain within the firm's risk appetite. And reporting is important. It's always important in this aspect of the professions. They collaborate with front office, right? To do what? To align risk assessments with trading strategy. You can see, this is very interesting to see that actually there are two the opposite forces here, because when we are in front office and we trader, we try to do everything to work around any kind of compliance, right? To make profit, because for the guys from front office, make money is the most important things, right, to do. And for the guys from middle office, risk department, risk control is the most important things to do, right? So they collaborate together to ensure that you can make a very creative and good strategies, but you know how to control the risk out of it, right? And the last, aspects of quant risk I would like to mention here, of course, when we talk about quant, it's very important that they develop risk models. They develop mathematical models to assess various types of risk, which predict potential losses under different scenarios. This is, I think, quant risk, to me at least, right? And I come to the third part, where maybe the most mentioned quant type in Vietnam, or maybe the only one that I heard about in Vietnam, is a quant trader. And well, there's many definitions for quant traders. But to me, quant trader is a loose term that describe either a traders who use quantitative methods to make trading decisions, or an algorithmic trading quant who designs and implements trading algorithms, right? It is a relative distinctions. And the boundary is very vague and depends heavily on their specific role and their work natures within a specific firm. I mean, a traders, when you mention quant trader, they can do both things. They can develop some strategy and they can trade, right? But if we try to, separate the two aspects here, as an algorithmic trading quant, normally these persons specialize in developing, implementing, and optimizing automated trading strategies using mathematical models and computer algorithms. And they have a focus on automated high-frequency trading strategy. I really want to emphasize the word high-frequency trading, HFT here, because normally, if you talk about decisions that you will make after 5 or 7 business days, is not really the work that an algorithmic trading quant normally do, right? They often deal with very high frequencies, I mean millisecond trading, right? And the constant monitoring and backtesting is very important, of course. They have to backtest thoroughly, carefully their strategy to hope that it will work in real life. I mean, and as a traders, what they normally do, right? Normally they are concerned with market data analysis. It's important for quant trader, and making trading decisions based on quantitative analysis, algorithm design by algorithmic trading quants, etc. Run a lot of backtesting, right? That's the theory. But here's what I heard and what I saw in my professions. Right, investment bank in France, it's not exactly the same, right? I think that in investment banks, in French investment banks, things change a little bit. I mean, when we even if you work in front office services, right, and you are a front office quant, I saw a lot of my colleagues, they started as the front office quant, and then they move to the trading divisions to become trader in many different services. I mean, in commodity, in interest rate, so fixed income service, and right, people like us with the very strong background of front office quant, now they become a trader. Can you call it quantitative trader? I think it is, but what they do is and what they actually do vary a lot and depends a lot on their specific role and the nature of the work of the firm as well. So we try to separate things here, but I mean the line is very, very thin, right? It's one trader to me. Right, so the list I mentioned here is far from some exhaustive one, because we observe in the market many more different quant types. I mean, globally, in London, in Paris, in Wall Street, in Singapore, in Taipei, in Hong Kong, in Tokyo, different quant types, like quant developer, quant ALM, stand for access liability management, quant in model validation, which is very, I mean, popular in France, in Paris. Quant in catalyst team as well is something quite rare. I observed once in my firm, but I don't see elsewhere. Besides, people with quant profile can work in other services, such as portfolio manager in hedge fund, in asset management firms, or quant in insurance companies. And I would like to come to the part that I mentioned before. I think there are three important aspects to consider here. The first one is mastering the certain materials in mathematics. Advanced probabilities, like conditional probabilities, conditional expectations, and stochastic processes. And I would like to emphasize that in this world, we do a lot of stochastic processes, right? The second thing I would like to mention is numerical methods. You should be strong with numerical methods, such as Monte Carlo and partial differential equation here. The two things are very important. Monte Carlo is easier and more popular, but numerical solutions in partial differential equation normally is faster and, I mean, more powerful. But in some sense, I mean, fundamental subject in statistics, fundamental engineer and optimizations can come in handy for sure, right? the part the mathematics for you. The second thing is operational in OOP oriented object programming. I think is very important. Strong in algorithms and in terms of programming language, C++ and Python seem to be the guys for you. But sometimes in certain services that I know very well, they actually use older languages such as Ada. Right. And to be operational and to be comfortable in this field, a sound knowledge in finance is very important as well. Deep understanding for financial instruments, from basic products to complex ones, is important. The fundamental understanding in financial market is important as well, right? So that the three aspects that I would like to pick as essential things to to survive or to develop in this profession. So thank you for listening.